Good evening, everyone. 저는 Win Marshal이라고 하는데요. 발표 전체를 한국말로 할 수 있는 능력은 안 됩니다. 그래서 양해 구하고 영어로 발표하겠습니다. 바로 앞에 교수님이 엄청 잘 발표해 가시고 제가 별로 설명할 내용이 있을까 싶습니다. So, once again, good evening, everyone. My name is Marshal, BRONZEWALL. I'm the Global Business Director at Innospace. I'm one of the founding members of the company. Innospace is today I plan to give you an overview of our company, what we've done, what we've accomplished so far, and what's our direction in the future. And then I want to talk a little bit about what kind of role does composites play in space vehicles. All right, so it's not a comprehensive look, but then I want to talk about how composites are being used today and how we plan to use the composites. So that's an overview of my presentation. To quickly talk about my company, Innospace is an aerospace and defense startup. We were established in 2017. Our headquarters is in Sejong, very close to Daejeon. And close to our headquarters, we have 3 plants. We have Sejong Plant 1, which is our solid fuel manufacturing and R&D. We have Sejong Plant 2, which is our rocket component manufacturing and integration facility. And our Cheongju plant, which is quite near to our Sejong plant, this is our rocket integration facility. We also have an office on the outskirts of Seoul in Dongtan. And so in Dongtan and Sejong, we have our R&D spread out. So in Korea, we're about 127 members. We have a Brazil subsidiary in São Paulo, and we also have a subsidiary in Europe and Paris. So globally, we are about 135 people and growing. 1 hour away from our HQ, we have our test facility in Kumsan. This is the only commercially available test facility in Korea. Just to quickly run through some of the history, after we've been set up in 2017, in a very short time, in less than a year, we were recognized as a supporting business for the defense agency, DTAQ. And in 2019, we set up our test facility. By 2021, we completed the development of our 15-ton hybrid rocket engine. In 2021, we also received the operator's license to launch from Alcântara, Brazil. And in 2022, we signed our contract with the Korean Air Force. They run the launch site in Brazil. So we signed a contract with DCAT, a collaboration contract, and we also signed a commercial contract with the Brazilian Air Force, CCZ. In March this year, we successfully launched our first stage. We had a DCTA payload on board. So we were the first hybrid rocket company that launched successfully using its original engine on the very first try. In terms of funding, including our pre-series in 2019 up to our pre-IPO, we have secured up to $70 million in our funding. This is our team. We have a very elaborate team. We have some of the best talents joining us from all over Korea, the aerospace industry. Dr. Soo-jung Kim, he's our CEO and founder. He did his PhD at Hangongdae, and after that he did his postdoctorate in Israel IIT. After that, He worked for Hanwha Aerospace for about 2 years, and then he set up our company. Here you see our technology experts, our business experts, and then our finance experts. So this is our team. Our organization, like I mentioned, we have about 135 members. Majority of them, 46% of our members are in the R&D. Of the 46%, more than 60% have advanced degrees in our R&D. So this is us and our team. So in a very early stage, after we started up our company, we started working together with some of the very popular names in Korea. We have supplied components to Hanwha, LIG, Kolondek, and so forth. We have technology cooperations with some of the most advanced aerospace industries in Korea, and university research cooperations with Korean universities and universities abroad. So I want to quickly run through our business model, our core product, what market we operate in, and things like that. So what you see here is our business model. We have a product part. We manufacture, design, and supply rockets, a hybrid rocket engine, sounding rockets to many of our clients, and we design, manufacture, and supply rocket and missile components. This is our core business. We are a Korean launch service provider launching from multiple launch sites across the globe on our Hambit family of rockets. I'll talk about it more in detail in the next few slides. We also provide rocket engine test and evaluation services. We are the only commercial entity that can do this rocket test. We can test up to 20 tons in our Kumsan facility. We're also building another facility down south in Kohung, where we will be able to test up to 200 tons. This is our product lineup. We call our rockets Hambit series. The first in the series is Hambit Nano. Hambit Nano is a 2-stage rocket. The first stage is a 15-ton rocket engine. The second stage is a 3-ton. On Hambit Nano, we can carry 50 kilograms to a 500 SSO when we launch from Korea. All right? So what we do is by clustering our first stage rocket engine, we're going to increase our payload capacity to 150 kilogram on Hambit Micro. As you can see, the first stage is a cluster of 4 rocket engines. Further clustering into 3 stages. On the first stage, 7 15-ton rocket engine. Second stage, 4. And the third stage, single 6-ton rocket engine. We're going to increase our payload capacity to 500 kilogram. And like I mentioned, when we launch from South Korea. When we launch from Brazil, which is close to the equator, these payload capacities will be much higher. One of the important things here is that we are going to start launching Hambit Nano in the 4th quarter of 2024. And in 1 year's time, in 2025, we will be ready to launch Hambit Micro. And Hambit Mini will be ready to launch in the end of 2026 or in 2027. And we're able to do this because we leverage hybrid rocket technology. Let me quickly talk a little about our technology. With our hybrid rockets, we plan to service the small satellite launch market. As you can see here, that starting in 2017, more than 70% of the launches to the low Earth orbits have been small satellites, and it has drastically increased over the last 3 years. So when I talk about small satellites, it is a satellite that is under 500 kilograms. It will range from a CubeSat that can fit on your palm top to about a mini fridge size small satellite. So The market, we're seeing a trend where the market is moving away from heavy, large satellites to smaller satellites, like the professor just mentioned in his previous presentation. This market is expected to grow. In the last decade, in the last 10 years, if in the entire 10 years, there were only about 4,666 small satellites that were launched. And in the next 10 years, it's expected to increase to about 26,000 small satellite launches per year, for the whole decade. So that is about 2,600 small satellites each year, right? This is happening because many of the large satellites are being replaced by small satellite constellations. So a group of satellites put together can actually do the work of a large satellite, sometimes even more. The advantage of this is that when we want to replace or upgrade the technology, it is possible by just replacing 1 or 2 satellites in the constellation. So that's the market we plan to operate in. And like I mentioned before, the reason we can scale up our payload capacities and we can move this fast in the market is because we leverage hybrid rocket technology. There are basically 3 kinds of rockets. The first one is a solid rocket. As you can see, this is the actual solid rocket. It has a very simple structure, right? Because it has a very simple structure, you can manufacture it faster, but because the fuel here is volatile, it's explosive. And so a lot of care needs to be taken in terms of handling and manufacturing. So general people like us, we cannot build solid rockets. Liquid rockets, on the other hand, you see this is a liquid rocket engine, and it is very complex in structure. It has many parts, right? So it takes a long time to develop, and it takes a long time to manufacture also, right? But the great thing about liquid rockets is that it has thrust throttle ability, which is very important for inserting a satellite into orbit. Hybrid rocket, on the other hand, is the best of both worlds. It has much simplicity similar to that of a solid rocket. And because we employ electric motor pumps and a main oxidizer valve, we can control the thrust of our engine just like a liquid rocket engine, all right? Also, the fuel that you see here is a paraffin-based fuel, meaning 90% of the fuel is made out of the candle wax, candles that we use commonly at home. Our 2 things that make Innospace differentiated from the rest of the hybrid market is that our fuel has an 8 to 10-fold increased performance in the market, and we're the only people in the world that have developed an electric motor pump. And this is the only rocket that is launched, hybrid rocket that is launched with an electric motor pump. 2 other things that is really important about hybrid rockets is that hybrid rockets have 0 TNT. That means it is not explosive. Because it is not explosive, we have absolutely no handling costs, and we can manufacture at a very low cost. Hybrid rockets also have a very low environmental impact during launches. All of the technologies that we have in our company have been accumulated over 20 years. So the entire technology, including the rocket fuel, every single technology in our company has been in-house bred. It's made in our company. It has been developed over 20 years. And we have all of the infrastructure needed for fast manufacturing to build up our launch cadence. What you see here is our fuel manufacturing facility. We not only have the facility, but also we've resolved some of the major problems with our fuel. even NASA and Stanford, they're still working on designing complex geometry like this, and also they have not resolved the cracking issues either. This is our test facility in Kumsan. We have both a horizontal test bed and a vertical test bed. We are able to test not just our rocket engines, but also we have a facility to test our electric motor pumps. What you see here is the 15-ton rocket engine. The engineering model of our 15-ton rocket engine is on display in our booth downstairs. Not only a launch vehicle, we also developed a portable launch system, which means that with our portable launch system, we can launch anywhere in the world. This has been transported to Brazil, and we made our successful launch on our portable launch pad. This is a video of our portable launch pad erecting the launch vehicle to the launch position. What you see here is the launch video, our successful launch in March. This is in Brazil. The name of the spaceport is Alcântara Spaceport. Professor Lee talked about guidance and navigation control. In a bit from our onboard camera, you can see how the roll thrusters start firing so that the rocket can be controlled precisely. This is the onboard camera. Now you can see the roll thrusters going off, smoke coming out of the rocket on either side. This is the GNC that Professor was talking about earlier. This is controlling the rocket to turn, bring it into the right position. When we launched in Brazil, we had an Air Force payload. The Air Force were testing a navigation system, inertial navigation system. So on our very first flight, a suborbital flight, we did have a customer on board. So moving to our next, this is our strategy. We want to launch from around the globe. Right now, like I mentioned earlier, we have the operator's license to launch from Brazil. We recently, in August, we signed a contract to launch from Australia, the Arnhem Spaceport. Right now, we're contract negotiating with Andøya Spaceport in Norway. Eventually, by 2026, we hope that the Korean launch site for commercial entities like us will be ready. On 3 of our launch vehicles, Hambit Nano, Micro, and Mini, by 2026-27, we want to come to a capacity of launching 35 launches per year. And that's our goal. Now, to talk a little about something that is related to carbon composites and launch vehicles. Carbon composites are actually, as you know, carbon composites have mechanical properties that makes it really strong, even in high temperatures. Not only that, it has extraordinary strength and stability. Carbon composites have been the early usage of carbon composites have started even from the Apollo program. The heat sink, not the heat sink, it's the thermal insulator on the capsule, on the Apollo capsule, was actually a carbon composite material. It has been used from the Apollo program long ago, and right now, as far as I know, there's no space program that does not use carbon composites on them. This is the SLS rocket, which is one of the main horses that will be working for the Artemis program, bringing people to the space lunar gateway. You can see the lunar gateway here, and it will bring people to the moon. Many of the structures here, at least even 8 meters long carbon composite structures, are being built for the SLS rocket. The latest Artemis spacesuits, they also have a lot of carbon composite materials which increase the mobility for our astronauts. This is the lunar gateway. Much of the lunar gateway has been manufactured with carbon composite. Even the roll-out solar array has been manufactured with light composite materials. You all know about the James Webb telescope. The back panel that is holding these golden mirrors are all composite materials, very thin composite materials. The Orion spacecraft, it's also going to be using a thermal shield, all composite materials, and the solid motor casing is also carbon composite. Talking about Innospace on our rocket, you saw this video earlier. This is the engine. The engine casing, the chambered tube, has been manufactured using a carbon composite. Our nose cone is manufactured with carbon composite. We have pressure tanks in our rocket for nitrogen, which supplies the nitrogen for our roll control. And for many of the systems, that is carbon composite tanks, and even our helium tanks have been carbon composite. Many of the components here in our TVC nozzle, thrust vector control nozzle, are also using carbon composite. To talk a little further, we have conducted some studies which indicate that if we use more carbon composite material, it is going to increase the efficiency, right? Carbon composites, even though they have great strength and work excellent in high temperatures, they are lightweight and would help drastically to reduce weight for our rockets. Even in a rocket nozzle, the rocket nozzle environment, as you know, has extreme high temperatures, extreme high pressure, and very high velocity in the rocket nozzle. But in spite of that, carbon composite materials can be applied here and drastically reduce our weight. The studies that we've conducted show that right now on TLV, when in our nozzle, the total weight weighing about 155.7 kilogram, by applying both CMC and carbon composite materials, we can reduce it by almost 21%. All right, so not only in our engine, for our engine casing, but also in adverse environments, carbon composite can really be of much use to us. So, as I mentioned, we have now applied carbon composite for our combustion chamber, our rocket nozzle, and in composite pressure tanks. We are looking forward to different partners, Korean partners, partners abroad, to actually help us reduce weight on all the other parts, especially on our liquid oxidizer tank. If Korea improves in its cryogenic carbon composite capacity, we will be able to use, we would highly desire to use a carbon composite tank on our rocket, which could drastically reduce our weight. We plan to change many of the structures, even the skin, which currently we're using aluminum alloy and stainless steel. We believe that many of these can be replaced by carbon composite components. So carbon composites, for us as a launch company, for us as a launch company, even if we reduce 1 kilogram on the launch vehicle, it means we can either go higher or we can take more payload to space. So with our plans, reducing, changing aluminum alloy to carbon composite and many of the other structures and other components, we are looking forward to a drastic reduce in our weight, in our launcher weight. And therefore, we'd soon like to see at least initially a 10% decrease in our weight, which will allow us 30% increase in our altitude capacities. Now, if either altitude or we can increase the payload on our launch vehicles. If we increase the payloads on our launch vehicle, it means it would allow us to bring the price per kilogram for our rocket, which would only increase our competency in the market. So Innospace, as a Korean company, and as I mentioned, we plan to launch at least 35 times a year. And to have more composite components on our rocket is something that we highly desire, and we welcome all kinds of partnership and research in terms of carbon composites. Thank you, everyone. Thank you very much for listening.
네, 감사합니다. Thank you for your great presentation. 예, 상당히 이노스페이스에서 많은 진보적인 연구 개발을 하고 계신 것 같습니다. 질문 있으시면 질문 받도록 하겠습니다. So once commercialized, what do you foresee as the applications, main applications of the LVs?
Right. The launch vehicles, the lineup that I showed you is mainly for low Earth orbit satellite, small satellite insertions into orbit. But if all goes well, we could also use our hybrid rockets for space tourism because it's absolutely safe. So that is our very long-term goals. But before that, you know, like Pak Sanim, the professor mentioned, we can increase our competency by reusability. So once we start our lineup, our next goal will be to bring reusability into our launch vehicles. And then after that, you know, space tourism.
Okay, thank you.
Thank you.
예, 다시 한번 오늘 마지막 발표해 주신 박사님께 박수 부탁드리고요. 네, 협회에서 드리는 감사장과 선물을 드리도록 하겠습니다.